Hello class, welcome to segment 7 in lab 3, and in this segment we're going to sort of continue what we were talking about with functions, but take a bit of a closer look at a special category of functions which are referred to as casting functions. And the whole idea behind these functions is it's a way that you can convert from what's referred to as data types. You can convert from one data type to another, or put in maybe simpler terms, it's a way you can convert a textual item to a numerical item, or vice versa, if that might be an objective of yours. So the reason why this is important is because when you go to read in data from a file, by default, all the data that you read in from a file will be treated as something that's textual. Even if your file contains all numbers, the computer is still going to treat everything as a textual item, which is probably not what you want to do, because if you try and do math with textual items, that may not work out very well. After all, a textual item is treated basically like something that has words in it. And I don't know about you, but I don't know what hello minus world is. I don't know what that equals, and neither does the computer. So the computer is just going to tell you, I don't know what you want me to do. And then some sadness and frustration might ensue. And so let's try and do something to avoid all that. And that's the goal of this particular segment, is to try and avoid all that by introducing you to this idea of casting functions, which allow you to convert textual items to numerical values if those textual items actually are numerical values. So here's what we have. So this is just going to sort of demonstrate what exactly we're talking about when we mean a textual item. Whenever you see a textual item printed to the screen, typically it's going to be printed as something that's contained in quotes. So as it is right now, even though our human eyes can see that this is in fact a numerical value, the computer doesn't see it that way because we have this set of quotation marks here. And these quotation marks basically mean the computer is going to treat this as a text item, or it's going to treat this like a word or a sentence even, and it's not going to actually treat that as a number, even though we can see with our own eyes there is in fact a number contained within the quotation marks. So now the question becomes, how do we actually get the computer to treat that textual item, which actually contains a number that we're trying to get at? How do we actually get that number out of there and get into a form where we can actually do some math with it? So that's where the casting functions enter this story. So first I'm going to go ahead and demonstrate, let me actually go ahead and disable that. So first I'm going to go ahead and demonstrate, well actually let's go ahead and introduce what these actually are. So sorry about that. So this str, and you'll notice that these are all highlighted in a purple color here. So this str takes some value and converts it into a string. So if you wanted to take a number and tell the computer to look at it as something textual, then you would use this function. Probably won't be using this specifically for the programming project, but do just be aware that this str, this string function, does in fact exist. And I'm actually going to go ahead and comment that out because it's not particularly relevant to this particular segment. And here we have int, which takes some value and converts it into an integer, if at all possible. You know, an integer is actually something that is numerical. But you may notice that here, and here I have the variable x, so we're saying take the variable x, take the value of x, which is holding onto something textual, and convert it into an integer. But you'll notice that our variable x here contains a decimal point. And in fact, if you were to try and do this right now, you would actually get this error message saying invalid literal for int with base 10, yada, 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 and all the other stuff that goes with the lovely error messages. Basically telling you that the number, the thing that you tried to convert into an integer is actually not an integer. There's no way to actually convert it into an integer. Technically, that's not true, but that's the computer's way of just saying, I don't know what you wanted me to do with this. So that's where this function down here enters the story. And this float function takes a number and then converts it into a floating point number, which is just a really fancy way of saying a number that has decimal points in it. And since our quote-unquote number, literally, our quote-unquote number does in fact have a decimal point, then the function that we actually want to use is the float function. And sorry about that. Let me actually do this so I don't do that anymore. So that's the whole idea here. So take the value of x and convert it into a floating point number if at all possible. And if I want to, I can print out the value of x plus x. So if those are in fact, well actually let me do this. If those are in fact numbers, then we should get something that's, well actually let me go and demonstrate how we can tell the difference between a textual item and a numerical item. So if I were to try this right now, you can see can't multiply sequence of non-int of type string, which is basically a way of telling you tried to multiply two textual items together, or you basically did the computer's equivalent of multiplying the word hello by the word world, which I don't know what that is either, so we're not even going to worry about that. But what I can do, so here just having float x doesn't actually convert x, does not actually replace the old value of x with the new result. This just says, this is basically just a one-step process of take x and convert it into a number. And then that's all it does. If you want the computer to remember what that result actually is, then you would have to do something like this. So the way the computer is going to read this, so up here it just says take the value of x, convert it to a number, and that's the end of it. Here on line 12, we've added an extra step to the process. So here we have take the value of x, convert it to a number, now take that number and put it in x. So now this, by adding this extra bit on line 12 here, so again, notice the difference between the two. By adding this bit on this extra bit on line 12, now the value of x is actually going to take on a numerical entry after it runs this statement on line 12 here. So again, just as on line 9 means take the value of x, convert it to a number. That's it. The value of x is still unchanged. But on line 12, we actually are changing the value of x. And the way we can tell that is because we have x equals something else on the right-hand side here. So here, we're taking the value of x in, converting it to a number, and now that old number replaces the old value of x, and the old value of x was this not so pleasant textual item. So if that actually did change the value of x, then we should get a different result. You can see we don't get an error message. We do in fact get the result of 50.25 times itself, or another way of expressing that is 50.25 squared. Versus if I don't have this statement on line 12, you can see we'll get the same error message that we started with, because without what's on line 12 here, the value of x does not actually change. Here you're just getting a result that gets lost. You get a number back, but you don't actually remember what that number is. By adding this bit on line 12 here, you can actually remember what that number is. You can have the computer hold on to that result as opposed to just taking it and throwing it out the window into the river. If the computer actually lives by a river, but that's kind of irrelevant. But if you want, and this kind of goes back to the idea that I talked about in variables. If you want the computer to hold on to something, if you want the computer to keep track of something, make sure you tell the computer to save it. Otherwise, you might get confused when you start seeing this, and you might be looking at line 9 saying, hey, I told you to convert it to a number. Why don't you convert it to a number? And the reason why is because, yeah, I converted to a number, but you didn't tell me to save the result. That's basically what the computer's saying here in so many fancy words and symbols and techno babble and all this other mess in the console. And then hopefully you'll remember what I talked about, and remember that you have to do this if you want the computer to actually remember the result that you got back from converting the item from a textual entry into a numerical entry. So if you want the computer to remember something, you better put it in a variable. Otherwise, the computer is just going to discard it, forget about it, and that's the last of it. So make sure whatever you want the computer to remember goes into a variable. In this case, we want the computer to remember what we actually got back from converting something from a textual item into a numerical item. So after that little pep talk, not such a little pep talk at all, actually, the last thing I want to introduce, and this is just for the sake of completeness more than anything else, you don't really have to worry about this too much, is if you want to convert something to a Boolean. Basically, the way this works is if the value that you put in here, so here I'm going to use y instead of x because I want to avoid odd behavior. If the value you put in here is not 0, you'll get something called a false, or excuse me, a true. If it's not 0, you'll get a true, and if you put a value of 0 in here, you'll get a false. And if we want to, we can actually demonstrate that, but you don't necessarily need to know this for the project. So that's y, and then I'll tell it print out what the result of bool y is. You'll see that's true, and then I'll change y to 0, and you'll see I get a false now. So just a bit of a side topic for the sake of completeness. As long as we're talking about data types, I figure we might as well talk about Booleans, which take on a value of either true or false, 0 or 1. Actually, let me reorder that. True or false, 1 or 0. So that the things that I said are actually in a respective order. But that's going to do it for this idea of casting functions. And I did that thing with the screen again. My apologies. But that's going to do it for casting functions. And with that, I will see you all in the next segment.